This video will discuss the difference between discrete and continuous data. Now, why it's important to know the difference between discrete and continuous is because when we are making our graphs, we need to know whether the points, the ordered pairs should be connected or whether they should not be connected. So when our data that we're graphing is considered discrete data, then the points here should not be connected because the data is only data that is the numbers in our data are counted, or they can only be whole numbers. In other words, the points in between, the decimal points in between, we don't want to include what's in between these points. But if the data is continuous, that means that the numbers that go in between the points here, we want to include them. In other words, continuous data, the data can take on any value in the interval. So what that means, if our interval is 1 foot to 2 foot, if that's our interval, and it's continuous, that means that we could have stuff that's in between 1 to 2 feet. So we could have like 1.5 feet. So we want to include that stuff that's in between these points right here. So that is when we would connect them. When we want to include the fractions and the decimal, the numbers in between the whole numbers. So let's take a look at some examples here. So for example, if we were going to graph the height of a horse, that is considered continuous because over the course of time, the horse is continuously growing, and it is possible for the height of the horse to be 2.5 feet tall. So we're including fractional or decimal values as well. Another example, let's say we were talking about how long it takes you to complete a task. It could take us 3.4 seconds to complete a task. So when we want to include the decimal or fractional values, like these examples here, that is when it's continuous. Now, discrete would be if we were going to graph the number of people that are in our class. There can only be, for example, 30 people. You can't have 30.5 people in a class. That's not possible to have a half of a person. Let's say we were graphing the number of TVs in people's houses. You can only have a whole number amount of TVs. There cannot be any fractional parts of a TV. For example, 15 TVs. We cannot have 15.5 TVs. That's not possible. Okay, another example would be the number of puppies in a litter. You cannot have a 0.4 of a puppy. You could have, let's say, 6 puppies, but you can't have 6.4. Another example is the number of questions on a math test. You can have 20 questions on a math test, but you can't have 20.4 questions. Okay, so let's say we were graphing the number of tickets sold and the cost of the tickets. So let's say we were going to look here. So from here to here, this is 1. So if I were to connect these points, what I'm saying is that in between 0 and 1, that's a half. So this, if I connect them, then I'm saying that there's a point right here. That there's a point at half and then 10. So a half of a ticket costs $10? That's not possible. So we don't want to connect the points because we don't want to include the stuff that's in between these intervals here. So this is discrete because we don't want to connect to the points. We don't want the stuff that's in between these. We don't want to include all these points that are in between. We just want to include the counting numbers because you can only buy 1 ticket or 2 ticket or 3 tickets. You can't buy 3.4 tickets. Let's take a look at this example here. It says a 20-gallon bathtub is draining at a rate of 2.5 gallons per minute. So I had graphed this situation here, and I need to decide whether I need to connect the points or not. So if I were to connect the points, then I'm saying that if this is 5 minutes and this is 0 minutes, that as the bathtub is draining, that I want to include a half of a minute. So in this problem right here, in half of a minute, that bathtub is continuously draining even in the fractional parts of time. So if this is 5 minutes right here and this is 1 minute, we want to include all of the in between. We want to include that in half of a minute, we want to include that data point there, that how many gallons remain. There's still going to be gallons that remain in a half of a minute. So we want to include all those data points. So this is continuous. Because it is possible to have a half of a minute. So this data point is valid. It has a fraction or decimal that in half of a minute, there is 18.75 gallons left in the bathtub. That's possible. We don't just need whole number data in this problem. So that's why it's continuous. Okay, another example here. If we have the number of DVDs we purchased and the cost, we cannot have, so it says here that one DVD costs $10 and we have 2 DVDs cost $20. So whether we should connect it, if we connect it, then we're saying if we go to half right here, that we want to include purchasing half a DVD, but that's not possible. So we do not want to connect the points because we do not want to include in between the numbers in between the interval. So this is discrete. We only want the whole numbers, not the fractional parts. Okay, if we take a look at this example, the fuel consumed in gallons and the distance that a pickup truck goes. So in this example right here, notice that the points are connected because we want to include what's in between 0 and 5 miles. So in other words, a truck can drive a half a mile. That's possible. And if you drive a half a mile, it will consume gas, gallons of gas. So because we want to include even the fractional parts, it is possible to drive a half a mile. And when you drive half a mile, it will consume gas. So because we want to include even points like this, that is why this is continuous. And we're going to connect our data points. Okay, our last example here, if we were going to graph the height of corn over the course of 9 weeks, we need to decide whether the points would be connected, so it's continuous, or whether it's discrete here and we're not going to connect the points. So if we think about it, if we have 1 week, we could have a half of a week in between a whole week, right? We could have a half of a week, and the corn is continuously growing even between 1 week and 2 week and 2 to 3. So the correct graph would be graph A because we want to show all the data in between 1 week and 2 week and 3 weeks. So this is continuous. Because again, the corn continues to grow in between the whole number of weeks.